Hello everyone and welcome to our new video. In this part, we are going to discuss about the understanding the levels of assurance in the SLSA. This is the part 3. So if you have not watched the previous two parts of the series, I will suggest you to go through them because this will help you to better understand the threats that the modern software development faces. Okay, so here we are seeing a diagram that we have actually previously discussed about the threats that can be introduced at the various stages of the software development. Now, in this video, we are going to see the real world implications, like what actually threats can be, how they can occur at the different stage, how the SLSA can prevent that. Diagram in our previous video. So if you have go through part 1 and part 2, where we have already developed. So let's see, okay, if you relate to the diagram that to the source repository. Basically, Linux is an open source project, so available as well, because definitely it can cause the issue, right? So the vulnerabilities into the Linux kernel mailing list. So basically, when you submit merge it, now this is where the all of the vulnerabilities. What this means is persons should review that code to cover some part of the vulnerabilities are getting induced in the code, and so this will help the code itself because a process which you have. The next one is the compromise about the source control platform. The Atlassian platform. Now, in this case, what hosted Git server and injected to malicious. Now, a better protectors. This is because of just the Git server itself, right? So they submitted the commits and into the branch, and when the code eventually got built and deployed, so the vulnerabilities also got deployed with it, right? So this resulted in the compromised code getting delivered along with the application, which was unknown to the organization, and this basically resulted in the vulnerabilities and the malicious code getting injected into the application. So you need to be ensured. This is more on the infrastructure side, where the proper hardening of the servers, proper restriction into the firewalls, and these kind of things will be preventing such kind of incidents into the Git server itself. Next is build with official process, but from code not matching the source control. So in this case, this is with the webmin. So basically, attacker modified the build infrastructure to use the source file which were not matching to the source control. So this is an important part to understand, that the build infrastructure, that is mostly your Jenkins server, the GitLab server, these are basically your build servers, and there are many more, right? So in the case of webmin, what eventually happened was that they were able to, attackers were able to modify the build infrastructure in such a way that the source code that they downloaded from the source control repository was not getting the files from it, rather it was downloading the file from somewhere else. Now, if the system was SLSA compliant, then the build server would have produced a provenance identifying the actual sources used and allowing the consumers to detect such tampering. So provenance and identifying the actual sources, this should be built into your system so that it only trusts the builds from the systems where you expect the source code to be. It should not be that it is downloading from some arbitrary source or even from some local other Git server which you might not be aware of. So this is how SLSA can prevent such a vulnerability. Now, next is the compromised build platform. So this is with the SolarWinds. So basically what attackers did was that they compromised the build platform and installed and implanted that injected malicious behavior during each build. So basically they actually hijacked the entire build platform, and they were able to install and implant and inject this malicious code for each and every subsequent builds. Now, if such a kind of thing is happening, so you will be delivering the application along with the malicious code. Now, this is something which you might not inherently do, but if such a thing happens, that will result in the compromisation of your application itself. Now, higher SLSA level requires that a stronger security controls for the build platform, and making it more difficult to compromise and gain the persistence on the systems where your builds are actually happening. there are multiple strategies to foil this if you are following the proper SLSA levels while implementing your application build infrastructure and running the application inside. Next is the use of risky dependency, that is AH recursively. So this is a case of the event stream where the attacker added an innocuous dependency where the later updated the dependency to add malicious behavior. The update did not match the code submitted to the GitHub, that is attack app. Now, this is where a case where where the dependency was eventually inserted and even the code was not matching to the GitHub. Now you can understand that such a kind of dependencies which we download from the centralized repository, such kind of issues can occur, and this will eventually become a part of your software, so it will be always be there, right? So the risk component will always be there along with the application itself. So if how the SLSA could have prevented was that if you were applying the SLSA recursively to all the dependencies, this would have prevented this particular vector, because the provenance would have indicated that it either wasn't the build from a proper builder or that the source did not come from the GitHub. So either of the two ways, that the dependency, find a dependency, you just Google it and download it, normal practice. But then you have to start building and compilation of that can result in the course. And you need to match you are getting the dependency where you are getting this in your application builds. This is the my magic issue, or the version of the packages from the references outage may also intentionally the packages they are downloading, and you make that result through the outages if some attacks for preventing the services. It does not directly address this kind, but there are ways to mitigate. You are having the dependencies, getting the back order to make it compliant, right? Not built by the CI/CD server. Now use leaked credentials to, and from which the malicious code, like the binaries which are access to the credential instead of just loading it, they got eventually compromised. So this is another case where they were able to upload an artifact which was not updated by the CI/CD. Now the provenance of the artifact in case of the GCS bucket would have shown that the artifact was not built in the expected manner from the expected source repo. So again, here the provenance is going to create the major difference, because when you are going to create and then you have a specific process of creating, so that will also help you. And when you expect that the final artifact will always be coming from a particular place, that is your source repo, and if the artifact is coming from some other place, then in that case this could have prevented the system from getting the compromise, right? So this is the case with the code cop. Now next is compromised package repository. So this is the attacks through the package mirrors. You would have seen there are multiple mirror sites which basically serves a lot of packages, and eventually you download all sorts of packages from these mirrors. Now these mirrors, there is a very fine distinction between the mirrors which are working for the purpose, because these are basically the mirrors which are providing you the download bandwidth and you are able to download the packages. But then differentiating between the actual mirrors which are supported and the mirrors which are created for the malicious activities, this becomes necessary, right? So researchers basically ran mirrors for several popular package repositories which could have been used to serve the malicious packages. Now this is very interesting because this is a case where the package's source is getting the compromise, right? Now, when the package source itself is getting compromised, then you have to be very careful with it, because there is a difference between now the packages which are served by the original repository and the packages which are being served by the malicious mirrors repositories, right? So again, here the similar to the above point that we just discussed, the provenance of the malicious artifact would have shown that they were not built as expected or from expected source repo. So again, this is where the provenance would have prevented such a malicious insertion of the artifact into the code and thus prevented such a kind of an attack. Next is trick consumers into using bad package. So this is the case of the browser file typo squatting. So attacker updated a malicious package with a similar name as the original one. Just with a very small difference, they uploaded the package. Now SLSA does not directly address this kind of a threat, but provenance linking back to the source control can enable and enhance the other solutions. Now, SLSA levels helps the consumer build the confidence that the software has not been tampered. So all of these cases are where the software were eventually tampered by one or the other way, whether it's through the source control, whether it's through the CI/CD, whether it's through the artifact, wrong build, wrong code. So there are multiple ways and multiple stages where the software can get compromised and can be tampered with, and this can be securely traced back to the source, something that is difficult if not impossible to do with the most software today, right? So you need to establish these kind of tamper proof checks in place so that you are always able to detect that the code or the build, which is the artifact which is coming, this is coming from the certified source. And you should be able to backtrack and you should be able to verify that this is something which is coming from the legitimate source. This is the way you can prevent the software tampering. Now, there are obviously certain limitations of the SLSA as well. We already saw some of the limitations where the SLSA were not covering that kind of the breaches, but those were also significant breaches, right? So there are significant number of dependencies in the supply chain for many artifacts. The full graph of dependencies could be intricately large. Now, this is where the case where the dependencies are further depending upon the other dependencies, and those dependencies are other on the other dependencies, which creates basically a chain of dependencies, and then getting a full view of what all dependencies are coming into the system, how they are getting built. Now, in this entire chain of dependencies, if some of the dependencies in between that chain is getting the malicious code, then eventually it will be split out across all the chains which are being interconnected through that malicious code, and they would also be able to cause the tampering and the changes from a security perspective, and that could result in a bigger issue. So again, this is one of the limitations for the where the SLSA is not able to implement, because in such a case, implementing the full graph of dependencies would be incredibly large, and it would not be possible to determine all the dependencies and going through and making sure that such a kind of issue is not affecting your application. Next is, in practice, a team working on the security will need to identify and focus on important components in a supply chain. This can be performed manually, but the effort could be significant. So again, there is a team for working for the security, and they will need to identify and focus for the important components in the supply chain. So these security teams are basically inbuilt into the organization, which should build the tooling, which should build the scanning and preventing these kind of packages getting introduced into your supply chain. And otherwise, this can now this when we talk about this kind of security, it can be done manually, or the efforts can be put in for the automation as well, and this could be significant in determining such issues. An artifact in the SLSA level is not transitive, and dependencies have their own SLSA ratings. This means that it is impossible for the SLSA 4 artifact to be built from the SLSA 0 dependencies. So again, this is like the way this is says is like that you don't have to serialize the things. That is, this does not mean that I have to implement the level 0, 1, 2, 3 like that, right? So eventually that is not the case. Okay, it is possible that you are creating an SLSA 4 level artifact which is having all the other built into it, and it is providing you the maximum security. So while the main artifact has strong security, risk may still exist elsewhere, right? The aggregate of their risk will help the software consumers to understand how and where the use of SLSA 4 artifact. So again, this is like you might the final artifact which has been generated compliant to the SLSA 4, but then since it has not given to the other SLSA levels, then there could be a risk which is lying somewhere else into the supply chain, right? And this might be affecting in one or the another way. So this is again a limitation directly for the SLSA. While automation of these tasks will help, but it isn't practical for every software consumer to fully vet the entire graph of every artifact. To close this gap, auditors and accreditation bodies could verify and assert that something meets the SLSA requirements, and this could be particularly valuable for the closed software source. So again, this is where there are certain limitations for everything, and this is where the auditors and the aggregation bodies also verify and assert that the SLSA requirements which has been implemented into the software development practices, and this will reduce down your risk. Obviously, there is a certain risk which still exists because the dependencies itself can be very large and they can be very varied and have a long dependency graph. So this is, you cannot detect every artifact in that case, but then if you follow the other practices, this will help the auditors to see that you have followed the 4 stages of the SLSA, and this will increase the trust in your application, that the application and the software which was eventually developed is particularly catering to the security needs and it is compliant to the SLSA level. So these are some of the real world challenges which the SLSA helps you mitigate, and following these practices will increase your consumers' confidence into the software itself and the application built in from a security perspective. So that's all for the SLSA, and this completes our series on the SLSA. Now, if you want to dig further into it, you can reach into the SLSA's official site. There they have discussed this in a lot more detail, where they have shown what all software, what all practices, what all packages, softwares, everything in detail, where what you can implement. And there are certain other sites which provides you the best practices to be followed for the implementation of the SLSA. So that's all that we are going to cover for within the SLSA series. If you find this video useful, then please do share with your friends and colleagues, and do like and comment on the video. If you have any doubts regarding the SLSA, we are going to try to answer your doubts and reach out to you in case you need any help for the same. So that's all for this video. So please subscribe to our channel for receiving such videos directly in your YouTube as we publish them. So YouTube algorithm will be allowing you to see our further videos which we try to bring in order to improve the overall knowledge from the security, DevOps, and cloud perspective. So that's all for this video. This is Ankit Mittal signing off, and see you next time. Bye.